She should be able to help you reset it.
I just barely started it. Oh my gosh.
Well, just close it. Don't even look at it. Close it.
You can go to the exam. We can do this another time.
You only have 4 hours to sit it.
Oh my gosh. Okay. I'm going to email her, and I hope she... What do you think? Should I just do it after we do our thing?
No, because it starts. Once you click it, it starts. It doesn't stop. You have to close out and just ask for help because you only have 4 hours from the time you open it to get it done.
Yeah.
So unless you want to not join us and you do it, you do your exam. But you said you need time to study. And they're doing a review tomorrow and Wednesday before the exam if you want to join in.
I'm going to do the review. I'm going to X out of the exam. Okay. And then, because what?
They're saying that the time keeps running. Even if you X out, the exam keeps running.
Yeah, but it says 4 hours. So we're going to finish in about 1.
Okay.
Hopefully.
The 3 hours are good.
Yeah, let's do it.
I cannot believe I just did that.
Oh.
Okay. It's okay. Let's just review really good. Oh my gosh, I cannot believe I just did that. It's due on Wednesday.
On Thursday.
It's due on Wednesday. Okay, I'm going to email her. I'm going to email her right now.
So
with my time, my time zone says Thursday, but it's on Wednesday with your time zone, yes.
Oh, wow, you went all the way to the bottom then. It's like you can't completely skipped a couple of things. Oh.
Today is the worst day ever. I'm just saying it. It's the worst day. Okay. I'm going to email her real quick, and then let's just do the review, and then hopefully...
Sounds good.
Sorry, guys.
I'm going to download the Excel sheets they want us to use.
Don't click the exam. Don't click it.
The exam will group exam.
Oh.
So we all get like what they call not fail, but.
Oh my gosh. Okay.
Actions.
Okay, my group thing is loading. Okay.
Yeah. So. I have no idea. So this we can still take your exam.
I wonder if she has a phone. Oh, anyway, I'll try to find her phone number.
She usually does under when they have the
what do
you call it? Their introduction at the beginning of content overviews.
Okay.
Well, this group quiz has 45 questions.
Let's see, because there's a phone number there under overview at the very top of content.
Can you just tell me her phone number?
303-667-6821.
303. What was it? Sorry.
667-6821.
So 667-6821. Okay.
303. Yep, is the area code. Yep.
Okay, I'll call her after our group meeting. I can't believe I did that. Okay.
So just let you know, just an FYI. I just opened this group with quiz has 45 questions.
This week's review?
Yeah, so I don't know if you want to go to your exam or do this.
Okay. How about you guys start the group quiz? I'm going to mute myself and go try and call her.
Yep.
Is that okay?
Yep. That sounds good.
And then I'll come back.
I thought I opened it now. Where did it go? I'll just open it again, I guess. Okay, we're on question.
We're still making some tweaks because on the family, we got the family.
Okay, can you hear me?
Yeah.
She opened it. Oh, where'd Abigail go?
Well, she got an interruption.
Oh, okay. Okay, it's all fixed. Hallelujah.
Well, good. I mean, at least we don't have to do the test tonight.
What?
At least you don't have to do the exam tonight.
The exam? I'm sorry, you keep breaking up. I can't really hear you very well. Like,
My computer died.
oh no.
So I just got it up. I just didn't notice. All right.
Okay.
I'll try to get from the cell phone, maybe PC.
Group meeting quiz. All right, she fixed it for me, so
Awesome.
that was so bad. That's okay.
That's pretty scary, especially when you're not ready. It's like,
I'll do it, but okay.
So did you guys decide on which test this one would be, the number 2?
No, I just got on it. Let's see.
Oh, okay.
Paired sample.
So that one is what type of data? Is that qualitative or categorical? That helps determine which type of test. I would say it's,
Categorical, right?
Categorical.
yeah.
I agree.
And then how many samples? I think is it 2? It's two samples?
Paired samples.
Yes. Well, they're seeing if they're.
And it's an independent. So that an independent is a. Oh,
Yeah.
let me look at my little index cards that I created for myself. So it's asking the difference of two means. So the test is the difference of two means, which is going to be paired or independent.
That is the.
I don't think we're doing proportions, right? We're just doing a paired sample t-test or an independent sample t-test. I don't think it's an ANOVA because it's got to be more than 2, right?
The hypothesis, the X2 hypothesis test, right? So.
I thought the X2 was the chi squared.
Is that the cheese? Yeah. You're right. That's the.
Still talking about number 2, right?
Yeah.
Yep. About number 2.
Is it the cheese squared then?
I think it's a paired sample t-test.
Yeah, I'm thinking it's a t-test. It's just whether it's independent or paired.
I think it's a paired because we have 2. We have the Korean and the American, and they're saying if the level of education so made them more successful or not.
I still think it's cheese squared though, because it's they're seeing if they're dependent or independent. They're seeing if the country they're from makes them, education level of managers, startup companies. So education level is dependent on the country.
But you have to have in that you have to have 2 by 2, like you have to have 2 rows and 2 columns. Do we have 2 rows and 2 columns?
Country, right? Wouldn't country and then.
No, they're pretty much just saying like a manager that studied in America is more successful than a manager that studied in Korea.
Yeah.
That's the question.
Okay.
But what makes it paired though? That's what I'm not sure of. I'm thinking they're independent. Testing similar things, but they're not like it's not husband and wife. It's not it's just 2 independent. There's two countries. We're looking at similar things.
Well, that's the thing, though. I mean, let me just get the question straight. Is that these successful managers in Korea, depending on the level of education, did they come up with good results? I mean, they were independent and they're successful, no matter the education in Korea, rather than in the United States. Is independent of the country they're from.
What makes them paired, though?
I still don't get the question.
Isn't paired that they're dependent on each other? Like, if you pick a wife, you get a husband. In this, it doesn't matter who you pick, which manager.
It just says that is the level of education of managers, successful startup, is independent of the country they're from.
So if you're a manager, you're from Korea, you're saying then that will determine your success which is different to a manager in the USA.
Yeah, and then they're saying like, is that dependent of it says independent of the country you're from, or because of the country, like they made you successful.
Okay. So we're compared.
Got to prove the independent of the country you're from.
One set of data, okay. One set of data, but two measures. Which
I still think it's the chi-square because they're seeing if they're independent or dependent on that. That's the only thing that we've learned. The HO is that they're independent and the HA is dependent. That's the only thing I'm thinking. But so I'll put that and submit it and I'll see if I'm wrong. But
yeah, we should all do one each. I'll do independent. Elvis does pairs.
There you go.
Oh, we have one set of data. Compare the educational level of people.
Well, we have two because it's people who manage successful startup companies in the United States and Korea.
No, but the question is that we have these successful managers. We have this set of data of their education. And is this says that you want to determine if the education level of the managers, of the successful managers, independent of the country they're from. So Elvis is from Korea, and he had a master degree. Britain is from United States, has a master degree. Now, they both are successful. Does this really matter because they study in Korea or no?
No, but that's what they're saying. One set of data compared to education level of people who manage companies in the United States and in Korea. So they're comparing the education level. You know what I mean? So that was just my thinking, but I might be totally off. You might be right. I just I don't know. I was just telling you my thought process.
Yeah, anyway, it's just a stupid question.
I agree.
Here's my quiz. Oh, there we go. Okay. Trying to.
Next one. Okay.
Gosh, I printed out my notes and now I can't even find them. There they are.
Okay.
So what did you guys put for that one?
So I put paired data. You put chi-square. And Abigail, what you put?
Okay. See, these confuse me. These or the tests here. Okay. Next one. You're an attorney and wanted to determine if age discrimination was a factor.
I don't think Abigail is following.
What?
Abigail is not following.
You did number 3 already?
You see?
No, we're on number 3 right now.
Oh, okay, okay. Yeah, I'm still independent because I haven't figured out yet.
Okay.
The dependent yet. And that's why I went to grab my notes. I printed them and now I can't find them. And I've got some old notes, but it's like, oh, they're all disorganized.
Of course, right? Okay. So in this one, comparing. So would this be a test of 2 proportions?
Age discrimination. So that is quantitative. You want to determine both age or 2 both. This would be most probably. So then you would be. Ooh, this is proportion. I think it's. Go on. I was going to say it's proportion down. Test 1 proportion down is what I'm thinking.
You think it's test of 1 proportion?
Yeah, it's one of those 3. Is it 1 proportion? Because it's the same group, but then you're going to take like.
You're taking the 2 ages though.
Yeah.
So that would be 2 then, right?
And yep, because you got 2 groups, so you definitely got 2 groups.
Okay.
Is it the when do we do the chi-squared? I think I'm going to go with the 2 proportions. 2 proportions. What do you guys think?
I agree. Elvis, what do you think?
Yeah, we have 2 set of data, so.
Okay. So this would be random sample of universe extent. This is the one with the p-hat stuff, right?
When you do proportions, okay, so a random sample, total of 240 as heavy players of these 152 are male. Imaginary portion of male heavy players is different than the portion. So it's a difference, and those ones are. It's like the HO is there a difference, or H and the HA is. There's not enough evidence that there is a difference. Is that what that one is? It's different 2 proportions. Yes, so that would be 1 or 2 again, or the chi-squared. Which one is it? Not enough information for the chi-squared, right?
I think it's 1 proportion. Because they're testing. They're testing one.
They're testing only men.
What?
They're testing only men's.
Yeah.
Only men's are being tested. I mean,
So
they can
be
female players too.
1 proportion, then test to 1 proportion.
Mm-hmm.
Number 5. Effectiveness. That's going to be either a test 1 proportion or a not proportion, a test 1. Yeah. Test
Two
1.
different. Well, they're comparing the two different locks. So would that be the paired samples t-test? I mean, independent sample t-test? Maybe not.
Yeah. Yep. But is it independent or paired? Does it determine that one of those is easier to open? They had to time it. What else? They asked 20 questions. And then they record it again. Did they record it again? Yeah, so there's two different measurements.
So that's 25 for the times.
Did they only record it once?
Yeah. For number 5, is that what you're talking about?
Yep.
So is that a one sample t-test?
I think it's independent sample. Because there's 2 samples.
Two locks, right? 2 combination locks. And you got to record it. 25 students recording test with 1 lock and 2. You're right. Yep, I would agree. The independent sample. Do you agree, Elvis? Number 5.
Okay.
So the next one, is that the chi-square? Oh, never
Number
mind.
6.
Square is not a answer. Never mind. One sample. Paired samples. Confidence. So would it be, would it be confidence interval for 2 proportions, I wonder?
Six properties.
Gosh, I think we had this on our quiz too. It sounds familiar.
I recognize it as well. Independent sample, paired sample. Let's see, it's not one sample, not paired samples. So it's one of the last 3, right? Confidence interval for 2 proportions is what I think.
Because it's neither paired and it's not independent samples, T confidence.
That's the thing that it says that these houses, they're already being valued. So they're going to go again. So
Yeah, so but they have 2 appraisers and then they have 6 properties that they're looking at on both appraisers. Right?
okay, confidence with 2 proportions.
Do you think so? I could be wrong. I'm not sure on this one.
No, but like it makes sense because they already have a value. They can come up with a different value.
Okay. All right, let's do that. Wall Street Journal article on counting. So would this be independent samples T confidence interval?
Send that one to 45.
Confidence interval for 2.
Yeah, it's a percentage. So the sample data was also reported for accounting majors. So we got psychology majors and accounting majors. So there's 2 groups. So then it would be independent samples T confidence, I think.
That's what I put as well.
Okay. Number 8.
So 1 sample T confidence interval, right?
You read so fast.
Oh, sorry. Oh, no, it wouldn't be 1 sample.
So double stuff saying they have twice the filling of regular. You want to know if that is true. You take a sample of 55 double stuff.
And you're comparing it to the filling amount in regular Oreos. So you're comparing the 2, right?
You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos. So you're not even comparing those 2 yet. It's just saying you have to come up with, right? It's saying they don't have the information for the regular yet. They're just saying what confidence interval would be most appropriate if you're testing the double stuffed Oreos.
Yeah,
So is that a 1 sample T confidence?
I think so. Because I remember in tutoring, she had said if they don't say that they test it, then just assume they didn't. So we're
okay. So we're still just working with 1 sample then. Okay, I'd go with the 1 sample.
So 1 sample T confidence
T
interval?
confidence, yeah.
That's what I think. That's one notion.
I'm glad you remember that in your tutoring. I'm just thinking logically that's what it's saying. Which one from best defines notion? Significance level. Significance level is the probability of the type 1 error, right?
Yes.
The p-value is the first one.
P-value. Wait, so you're saying the p-value is the same as the significance level?
No, I was just saying the
Oh.
first answer belongs to p-value.
Oh, I see. So that's the next question. The probability. Oh. There you go. Suppose you can create a 95% confidence interval.
Yeah, that's the p-value. And what's alpha? Alpha is the significant.
I'll wait question number 9, right?
Number 9 was the type 1 error.
Oh, okay.
Yeah.
I was like, where is it talking about p-value here?
Sorry. And then 10 was the probability of observing.
Yeah, because I was saying number 9, the first answer belonged to p-value. That's why it wasn't that one.
Oh, okay.
And it happened to be the next question. So number 11. 10 when you've been told to report this by saying something like, we are 9%. Is that what does this mean? Okay, here we go, Britton. This only 1 chance there, which we know we can cross out.
I know. Don't do the bottom one because I put that one for every answer last time and it was wrong.
There's no chance here. I love that one.
Yeah, you and I both got those wrong. So is it the second one then? 90?
Yes.
Whew.
Especially if they use the true mean in there. If they didn't put true mean, it could be the top one. Sample means, but it says the true mean is, which is more accurate. So. Okay, we're up to number 12.
Take a sample of 100 adults.
Okay, large enough number. We have a P.
Isn't the mean equal to P? Or am I thinking something else?
Was it X divided by N?
Oh, you're probably right. But
That's the one I always get mixed up with. The mean is equal to the population mean. So is the P, is that a population mean?
yes.
So we can put 0.3 then if it is. And it doesn't say don't put it as a percentage, but I guess 0.30.
Yeah. Standard deviation. Is that 0.30 divided by? Oh, I gotta get my notes up.
Standard deviation equals, is that the one with the square root of N? Is the,
Yeah, I think so.
also depends which test you're doing.
Well,
Standard deviation is divided by the square root of standard, the number. So it's the standard deviation divided by the square root of N.
standard deviation divided by square. But we don't have. Oh, we do have the standard deviation.
We do?
Oh,
Didn't
okay.
we just? Oh no, that was the mean.
Yep. Come on, calculator.
So confused. Oh.
Standard deviation is divided by the square root of N of X random variable.
So would it be the? It wouldn't be 0.3 divided by n though. Is that?
It would be 0.03. 0.03.
So 0.3 divided by 100, right?
Yeah.
Is that right?
Or is it the
then?
square root of 100?
Yeah, so it's 0.03.
But I thought it would be divided by the square root.
Yeah. The square root
Oh.
is 110.
Oh, okay.
There you go. I feel like we're making this more complicated than it is because we're like
So
overthinking it.
so
I've got
0.03 then.
0.003. So what would the answer be,
Then-
Alpha? So I've got 0.003.
Well, if you divide it by the square root of 100 is 10. But if you divide it by 100, it's 0.003.
0.01.
So my answer is
0.03 then, right?
yeah,
How many zeros?
1.
0.03.
Oh my gosh. It was calculating right now. It doesn't want to. 0.30, right? Divided by the square root of 100. Did it do it?
Can't we use the Excel for this? One sample z-test. Is that the same thing?
Yeah, sure. Let me see if it helps.
Yeah. Standard deviation. What's the null oh, we don't have a null hypothesis, do we?
Okay. Finally got it calculating right. We'll have a sample proportion less than 0.25. The probability is Isn't that where you have to use the applet?
If we have a z-score,
So we have to figure out the z-score, which is,
I feel like there's an Excel for this. Wait,
Oh yeah, the sample proportion one. But what is that?
this proportion, because I want to be able to find it for the quiz, you know. The one proportion. Is that what you're talking about, Elvis?
Yes, that I'm trying to open, but it just opened something random.
So
n is 100, right? X is,
yeah, what? X was the, see, this is what I have for my thing. So if we do X, is it 0.3? And it's 100, 0.95, but we don't have a null hypothesis, right?
Yeah.
it's
And we
going to
don't have
be
what
less
type of
than. No, oh, the null.
What?
yeah, we don't have a null hypothesis and what type you're gonna do.
Yeah.
It's going to be less than for sure. Less than what? Less than 0.25.
So that was easy then.
Okay.
0.03. That was easy then with
0.03 is number 13, right?
Yep. So we
So-
put in.
wait a minute.
So is the null hypothesis 0.25?
Oh, and we do less than. Maybe.
So then the probability will be, if you get the z-score, put it in the normal applet.
Wait a minute.
Percent. So, but it has a different, it doesn't give us the standard deviation there, you know?
Do we need it?
Well, it doesn't give us the same standard deviation. From number 13, we have 0.03 and they have 0.0055 or 0.0433.
Wait a minute. What about number 12? What we got there?
The 0.3, because the mean is equal to the p.
Oh, sorry.
P hat equals x over n. Oh man, these questions are making me nervous for the exam. What?
It's gonna be a fun exam, this one.
Yes. So this is where we do, because we just found the p hat, that was the x divided by n. So the 95% confidence interval is the long equation that we have. The p hat plus z square root, right? Or no?
To get the z-score? Or to
Let me
get
show
the
you what I'm looking at.
probability?
Let me show you what I'm looking at and see if I'm just completely on the wrong page. So I was looking at this because we can, the p hat equals x over n, which is what we said, right?
I'm trying to find, sorry, the screen. I don't know what I clicked on that you guys did.
What, Elvis?
There you guys.
I'm trying to do this on the Excel spreadsheet.
Categorical data analysis.
So you think to do that equation to get the probability?
Oh,
So what was the X we said?
I actually, that's what I was thinking isn't right. Sorry.
Okay.
I'm just confused because that was the confidence interval, how to calculate the confidence interval, but we're not doing that.
We're just getting the probability. So, which I think is you find the z-score or t statistic, whichever one it is. And in this case, if we use the one proportion, is that negative? Do you have negative 5.767?
For the z-score?
Mm-hmm. On the Excel.
I got negative 5.704.
Yeah, I got the same.
So then what numbers did you put in? 0.03, 100, 0.95, and then
Oh.
did you put
Yeah,
point?
I put 0.3 for x, but it's 0.03. That's the standard deviation of the proportions.
So is x 0.3 then?
P is 0.3. What is x?
Okay, so
Thinking?
x is the sample, is the mean, whatever
Well,
proportion.
that's the thing though. The difference is not that much. I changed to 0.3 to 0.03. The difference is not that much for the z-score.
Mm-hmm. What is the x? Sorry. That's the sample mean?
X should be P, right? So you guys are right. X should be 0.3. I think you guys are right. So negative 5.704, we should be able to just punch into the Apple, key into the applet.
And do that as P?
Negative, because that's the Z score.
Oh, Z, yeah.
And then are we testing the left tail?
We're seeing, yeah, because we're seeing if it's less than. Let me double check on that.
Negative 5.704.
We're seeing if it's less than 0.25. We haven't put 0.25 anywhere, though. Oh, yeah, we did. That's the null hypothesis. Okay. So we do less than.
Which means everything to the left, right?
Yes. To the left of 5.704. So that's 0.000. All right.
I can't get mine to calculate on my applet. It's just going all the red lines. Maybe I'll reset. So do I color in the left before and then key it in?
Minus 5 though.
Take a sample of 100.
So
Yeah, it just spreads out mine. Just spreads out and says 5.8514 something at the top for my normal probability. Can you show me your applet? Mine is just not.
Because the
mine
standard
doesn't go to.
What?
Mine doesn't go to 5. It's minus 4 is the biggest one.
Oh, weird. Yeah, I'll show you mine. Let's see.
Let me see. Okay. Oop. At the top it says 5.85, or is that 5.05?
But it's 5.85, but this E negative 9 means there's 9 more decimal points in front of that.
Oh, so I did it the same as yours then. I just was thinking mine was wrong.
Yeah.
Wait a minute.
But
okay.
I wonder if we did the wrong standard deviation.
Yeah, could be.
Because let me stop sharing. Because in the describing categorical data, we did the mean of p hat equals p, right? Is that what we just did? Yeah, so that was I think I'm so confused because I think that, well, first of all, what test would we be doing? Let's figure that out first. Would that be the let's see, paired sample, one sample.
P equals 20.25, right? That's sample proportion of 0.25. So Z, to compute the test statistic, I've got Z equals P minus, why do I have PO?
That's the minus mean.
Divided by the square root of P. I forgot what my O means. Is that because it's the HO I'm talking about? The brackets 1 minus PO brackets divided by N. Is that familiar?
It sounds familiar, but for some reason I can't find any of my notes.
Equals X divided by N for sure. Z score equals critical value, so N equals sample size.
So should we skip this one and come back to it?
Yeah.
Yep.
Well, P is population proportion, so P minus PO meant population proportion for the null hypothesis. So it would be P, which would be 0.3 minus, what was the null? 0.25.
Divided by standard deviation.
Yeah. And the standard deviation then would be 0.25 brackets 1 minus 0.25 brackets divided by N square rooted.
So we did the wrong standard deviation there then.
You think so?
On 13, because you're saying a different standard deviation equation than we just did.
On really? Oh, that's right. It's always the standard deviation. Oh.
Yeah.
Unless I go back and it's a different type of test. No, we're doing proportions, so yep.
Wait, yep. So this is value. Yeah, you're right. You're right. Okay. You got this. Value minus mean over.
So we do have to change
the mean.
13.
Well, the mean is P.
Right. Yep. So that'd be 0.30 minus 0.25, which they want to see. They want to say, hey, what's going to be the difference?
0.25 minus the mean. Because it's value minus mean.
Value minus. Yes. Yes.
Minus mean over standard deviation.
Yeah, so what's the standard deviation?
What?
What's the standard deviation?
That's the square root of P, parenthesis 1 minus P, all over N. Minus P. Over N. So P is the 0.3. So 0.25 minus 0.3 all over square root of 0.3, 1 minus 0.3. Elvis, do you get what we're doing?
No, I got it. That was for the standard deviation of that formula. The P.
The standard deviation is square root of P, parenthesis, 1 minus P, parenthesis, all over N. And then you square root that.
But is the P is the null hypothesis. So is that 0.25?
No, P is the mean. That's the 0.3. P hat is the value that we were doing. Right? Maybe not. I don't know. That's what I thought.
So I've got P sample, I've got population, and then I've got population proportion for the null. Estimate P. Yeah. Because I've got P minus, because we got a P, minus the null hypothesis, which right now on question 14 is, I thought, 0.25.
So P is the mean. P hat is the value. I don't know. I'm going to do it as...
Because I don't have P hat on my statistic thingy for this one. My next ones have P hats.
P hat is the sample proportion, because we're trying to find the sample proportion of the people in town who invest in the stock market. So the P is 0.3, and that is the...
Okay, so is it 0.3 minus 0.25, the very first part of the equation, or are you guys doing something else?
I did 0.25 minus 0.3. Because you're doing value minus the mean.
Minus 0.3?
0.25 minus 0.3.
Okay. Okay. Man, I got to figure out why I have two different equations on here then. Okay, so 0.25 and then brackets 1 times 2. And so I've got now 0.25 times brackets 1 minus 0.25. So now am I on track?
What are you doing? Because I think we might be doing something different, because I'm doing the P hat 0.25 minus 0.3, and that's all over the square root of 0.3 times 1 minus 0.3.
Okay. Okay. I was doing the P hat one. Okay.
But
because doing 0.25 is the P hat.
This is giving me a larger proportion than 1, though. So that's not even possible, because probability can't be over 1.
Yeah.
I think we should skip this one and come back to it.
Okay.
So this was question 14, right?
Mm-hmm.
And just to make sure, on 13 was still 0.03, right?
Yeah, but I think that's wrong.
Yeah, because I was trying to find a different standard deviation and I got 0.21.
0.21 is part of it, right?
That's the standard deviation, right?
Yeah, and then you divide that by 100 and then square root it, right? Or is that wrong?
Oh, I forgot to
Yes,
square root
I didn't do the square root part. That's where I messed up. So let me see. The square root of 121.
This is driving me nuts. Let's see. So percentage of people, that's the p hat. 0.3 is p hat, right? You know what? I wonder, I think you might be right. Abigail, I think maybe I am getting them mixed up. Maybe it should be 0.3 minus 0.25 for the numerator.
Mm-hmm.
And then 0.25 times 1 minus 0.25 divided by 100. Square root that. 0.05 divided by that. Yeah, see, we're still getting greater than 1 though.
I've got a 0.043.
That's the denominator. That would be
that's the standard deviation. Sorry. And then I got to do the top part.
Still, like, I got like 1.1 probability.
Yeah,
that's not happening.
Yep, I agree. But standard deviation, I think, is the 0.043, right?
I got 0.1444, so I rounded to 1.5. 0.145 rounded.
Okay, so that's if you use 0.3 as, that's what I got at first too. But neither of them give us less than 1 for the probability.
Yeah, so that's our
Not
problem.
sure that it S. Oh, for the probability.
The question 14 is the probability.
Well, don't we key this in as our z-score? That's what we're doing wrong. You're supposed to plug that in now, 1 point whatever you guys got. What did you guys get? I got 1.155 if you round it.
Is that the z-score?
What you just did is the z-score.
Oh, that's why. So do we think it's 0.25 minus 0.3 or 0.3 minus 0.25?
0.3 minus 0.25.
Yeah, I think it's 0.3 minus 0.25.
Okay. So then, what number did you guys get for that then?
Are we coloring the middle and the shading the middle and the left, or just the left?
Just the left. Yeah.
So I got the probability 0.1243.
What did you use for the standard deviation?
I had, I hope I didn't close it.
Well, that's number 13. Oh, maybe you didn't. No.
I think I got 0.0433 was what I got.
And then what did you use for the z-score again? Sorry.
And then I did the 0.3 minus my z-score. I came out to a 1.154.
Okay.
And did I round that? Oh, I did not round it. I should do a 1.55. 1.155 is what I should have done. What did you guys get?
Divided by, hold on,
0.124.
So for the z-score, what did you put again? Sorry, I just recalculated it.
I've got 1.155.
Yeah, me too. Okay, so just to the left of that. So I got 0.876 for the probability.
Oh, so we're shading the middle too?
Yeah, because that's to the left of the.
Okay. Yep, so then I got 8.76.
7.
Are they wanting us to round it so it's 8.876 still? Okay.
Yeah.
3 decimals. So then our go back, that 0.03 should be what did I say? 0.43, 0.043.
Yes, 0.043. Did you get all that, Elvis?
No, but
Do you get the equation that we're using? It's lesson 16.
okay.
Section 3 for the equation. So then what is the mean of distribution? That was the 0.3.
Mm-hmm.
Okay.
Because the mean is equal to, yeah.
Okay.
E. Yep. And then the reason why I went with that calculation was because the first thing it started off was a P. It wasn't a P hat. And then we had to find the P hat.
Yeah.
So that's how I
That was difficult.
decided what it was. Thinking, those are the numbers I was using.
Okay.
So for question 13, what's the standard deviation?
That is 0.043.
0.04. And we got like what we use for P, like 0.003.
For what?
For the P, the formula is P1 minus P all square root on to n, sorry.
We did 0.25 times 1 minus 0.25. Is that what you're talking about?
Yeah.
That was part of the standard deviation though.
So then what uses a P value for question 13?
0.043 is the answer for 13.
We did 0.3 minus 0.25 divided by the standard deviation, which was 0.043.
Oh,
and
yes, this is for question 14.
Yeah, so that's for the z-score. But for 13,
Yeah, what we use as a P value for 13?
0.25.
Oh, we didn't have that.
On oh, crap.
Because I have a different number here, that's why I'm saying. I have 0.145.
You're right. I got that at first too, 0.145. And that's because we did not have the 0.25 yet.
Yes.
Yeah, you're right. Okay, I'm just going to put 0.145 and then 14, the 0.876. And then I'll submit it first and we'll see what we got wrong.
Okay.
Yeah.
Because you guys got a different number for number 13. Is that what you're saying?
Yes.
Yeah, because we were doing the standard deviation where we did 0.25 times 1 minus 0.25. And we didn't have that 0.25 yet until question 14. We only had 0.3. So if you do the 0.3 times 1 minus 0.3.
So you think we should have changed that out?
Yeah. I did that at first too. So 0.21 100 square root answer. Yeah, so I got 0.0458, but
yeah.
You got 0.145 for the standard deviation?
Yeah, that's why. So I'm trying to figure out why. Which is, yeah, at the end the square root, yeah, 0.145. So let me do the math better.
P times 1 minus P over N.
So it's point. Oh, okay.
So are we doing 0.3 times 1 minus 0.3? Is that what we're doing?
Yes.
Okay. I just did that and got something different. Divided by 100, right?
Yep. 0.045. Oh, well, it should be 46.
Yeah, 0.046. Okay.
So you think 13 is 0.046?
Yes.
Yeah, because we did not have 0.25 yet. We were using the 0.3 from up
Okay.
beginning.
And then the next one said, hey, but if it's 0.25, that's when we're supposed to use 0.25. Okay.
Yes.
Good catch, Elvis.
Yeah, seriously. Well done.
Well, I was getting lost for a moment. I was like, where did these numbers came from?
It's because we backtracked and then completely forgot we had backtracked and was still using the same calculations. Now, I wrote 0.046. Did I do that wrong for number 13?
Yep, that's right.
Okay. All right, so we're now on to, and then the 0.876 is still right for 14 because we did use 0.25.
Yes.
Okay. All right, so number 15. This is one I always get mixed up with, is the margin of error. I think I finally get it. Okay. Then put the margin of error lower and upper bounds below, rounded to 3 decimal points, P1.
So is this 1 proportion or 2 because there's a placebo?
It's 2.
2. Yeah, I agree. Okay.
My pen. Oh, here's my pen. All right.
So.
Okay, we can plug this one in.
Yeah, that's right. So it's to 2 proportions.
Yep.
And then we've got X1 being
15 out of 579. 61 out of. Do you think it matters who we use for X1 and N1 and X2 and N2?
Yeah, it does. That's why they always tell you at the end who's going to be P1.
Okay, so P1 is people who experience while taking. Oh, okay, so P1 is the 61.
Out of 1563, yeah.
563. And then the next one is 15.
Out of the 579.
579. Okay. Confidence level 95%. Type of test. Clinical trials.
Okay, so the margin error we always have to calculate. That's the one I always get mixed up with. Let me see which one I'm doing. This is 2 proportions.
What type of test are we doing now? Do we know or not yet?
Yeah.
Two samples Z test.
Yeah, but it's the P different by the second P, or?
Are we saying greater than, less than, or not equal to? Probably not equal to.
Yeah, that's what I usually don't change it unless there's a wording in the paragraph that says specifically. So I'm not seeing it say anything specific. to say it's greater than or less than, so I would go with the not equal.
Not equal.
Yeah.
I agree.
Yeah.
Okay, so margin of error is the 0.003 plus 0.029 divided by 2, right?
What do you mean?
That's the one we couldn't figure out forever. And then you sent us that link where she explained it. So you take the absolute value of the confidence interval.
Yes.
Okay, so 0.003 plus 0.029, and then divide that by 2. And I got 0.016.
Okay, but why did I get? Let me see where I messed up putting the wrong numbers in.
But they gave you the point estimate, right?
The point estimate is the negative 0.003, right? Oh, no, sorry.
Okay, can I check the numbers with you guys? So x1 is 15. n1 is 579.
No, we're the x1 is the bigger proportion because it says at the end that P1 is while taking AccuPro, P2 is do not take AccuPro.
Oh, okay.
Yeah, so hopefully.
So the margin of error is, and this is where I got, is the, I think it's on my, got to have the right formula for me to get it right because I was always getting it wrong. Margin of error is the, she said in there, it's the margin of error is everything where there's the plus or minus z times, is everything beyond that is the margin of error. So it is probably what we just did.
The margin of error, I think you're making it more confusing. All it is the both the high confidence interval and the low confidence interval. Don't put negatives, add them together and divide it by 2.
That's how we've been doing it so far, though.
Weren't we doing, we didn't do absolute value, did we?
No. I mean, I was just wondering, let's go, we enter the same data, so let's see what numbers we got. Do you, what's your confidence of interval?
Negative 0.003 and 0.029.
No, I don't have those.
So you got 0.013 as your
0.003 is my low. Oh, sorry, what?
Is 0.013 your margin of error?
No, I have 0.016. Let me make sure. So X1 is 61 and 1563, 15 and 579, right?
Mm-hmm.
And then 0.95 and then not equal to, right?
Mm-hmm.
So what's your lower confidence level, confidence interval?
Negative 0.003.
What do you have, Elvis? Do you have something different?
0.054.
I don't.
I'm trying to see this formula. I gotta have something wrong with the formulas here.
Maybe try to re-download it because that's.
Yeah, that's what I had last time.
Yeah. So, Abigail, for the margin of error, What did you do?
Added the two confidence levels together, so negative 0.003 plus the 0.029, and then
Okay.
divided that answer by 2.
So you don't put a negative, you take the absolute value because negative 0.003 is still 0.003 away from 0. So you're trying to see how big this interval is, right? So you just do the absolute value and then divide it by 2.
And then that comes to 0.016.
Yes.
I did that, or maybe it's because I used negatives in my answers. So I'm saying I did that before and it wasn't right. I must have been using negatives. Okay.
Okay, well, hopefully it's right. If it's wrong, I'll submit it first and then we'll know if it's wrong.
So then our answers is negative 0.003 and then 0.029, right, for the next two.
Yes.
Oh, I fixed it. I have the same one.
Oh, good.
Groups of objective experiences is different than the proportion, okay, which is not equal. Uses left skin. What are the appropriate null? So we already said the HO is P1 equals P2. So HA has to be P1 does not equal P2, right?
Right.
One.
Yeah.
Okay. Number 19. The value we got is 1.458 for number 19.
Mm-hmm.
0.145.
Yes.
P-value. Is there evidence? It is more than, right? So there's, it's larger than the 0.05. So that was the alpha was 0.05. Yeah, it's largest. So we fail to reject.
Mm-hmm. So the last one.
Is there sufficient evidence? No, I failed to reject. Okay. And then, oh, going on a roll.
This is a chi-test, right? Chi-square.
Yes. Independent.
Yes,
Yep. Get our chi-square going. Fill it in.
What did you say, Elvis?
Oh, this must be, I mean, like there are 5 datas here.
Mm-hmm.
Or 4.
And 2
groups.
columns. 2 columns and 2 rows.
I got 4 columns. Sorry.
Yeah.
I'm sorry, the least has to be. Sorry. You're right. 4 columns. I don't know. Some stuff I already have in here.
I mean, I didn't get really cool about this, the chi-square. It's like kind of the ANOVA test, right?
That's what I think.
Do you think it's ANOVA?
It's like I like
No,
it.
it's like the ANOVA of the proportions, pretty much.
Yeah. I like how you explained that. Yeah, it's just okay.
Yeah, I was getting that confused.
I've got 6.579.
Mm-hmm.
22.
Me too.
So how much was that, sorry? 0.79?
For 22?
Yeah, does your
Yes.
test statistic say 6.579?
Yeah.
Top right corner. And then it's 0.886. Now we have to round, right? Or
Mm-hmm.
0.087.
Mm-hmm.
Should we reject HO or not? It's still more than 0.05. So do we reject HO? No. Yes. Wait on. No.
No.
No, the p-value is greater than 0.05. Okay.
Yeah.
Oh, wait on. I didn't look at it. Is it no, young people to be more likely to be a night person?
No, you're right. It's no, the p-value is greater than 0.05.
Oh, yeah, because it's not independent that we're talking about. That's what we're talking about. Okay. All right. We have insufficient evidence to say that being a morning or evening person is not independent of age.
So the third one?
The last one.
Last one, yeah.
Last one? Not independent.
Yeah, you got to remember that not in front of independent. If you're failing to reject, you're saying that you can't prove it's not independent.
So for the next one, this is like the one we were confused on earlier, the proportion one, right? True proportion. This one confuses me. Okay.
P be the true proportion who graduated, who outperformed over a 5-year period.
So this is definitely with the Excel. So we just have to put the numbers in.
Mm-hmm.
One proportion.
We're using the one proportion?
Yeah, just one proportion.
Yes.
Because it's P, silly me. So we're doing 0.2
Let's see.
out of 200. Confidence levels 0.95. Now what?
0.2.
What's
0.2. What is 0.2? Is that the P?
The null hypothesis.
Okay. 0.2 is the mean then, right?
Yes.
And
Okay.
200. 50.
And we're saying greater than? Because they outperformed. Does that mean greater?
I guess so. 50 of these outperform. Let P be the true proportion of investment managers who graduated from. So P is 50 then? Is that what they're saying?
Yeah.
We got to figure this out on the spreadsheet.
So what
So
I'm missing.
is X 0.2 then? 0.02? No, 0.2.
I thought that was the null hypothesis then.
Oh. I'm just getting confused. What is X? I can't remember that.
X is the standard deviation, is the P, the square root of P1 minus P over N.
Oh. So P.
So 0.2 divided by 200, is that X?
No, but so we decided the P to be 50, no?
Yes. I think, yeah. Wait, no, because usually it's 1 minus point something.
Point something, yeah.
So maybe it's the point, maybe it is the 0.2. Oh, that would be 0.2. That 50 out of 200 is 20%. So it is 0.2.
Yeah.
Oh, the number's 50, but we want, does it matter if you put 50 in there or 0.2 as X?
0.2 because the calculations, we should do 0.2 with calculations.
So
the X we're calculating right now, like
yes.
it's 0.2 parentheses 1 minus 0.2 divided by 200.
Yes, 1 minus. Do we take the square root of that? Or no?
Yes.
No. Yes.
Yes.
Okay, yeah. Over 100 and then square root that whole thing. So 0.2 times. Answer. So I got 0.04. Did you get something else? Maybe I did it wrong.
Yeah. So before the square root, what number you got? Oh, you did it. Oh, you plugged it all once.
0.0016.
No, I got 0.0.
You got
I got
what?
0.0008.
Oh, so because the numerator is 0.2 times 1 minus 0.2,
Yeah.
and that's 0.16.
Yes.
Divided by 100 is 0.0016.
Yeah, but divided by 200.
It's 200.
Okay, sorry. That's where I was going wrong.
Oh, okay.
So 0.16 divided by 200, and then square root that. So I got
Yeah, so we got
0.028.
yes.
Okay. So that's our x then, right? 0.028. 0.028. Okay. So x is 0.028, n is 200, and then is the null hypothesis, is that the 0.2 then?
20%, right?
Yeah.
That's what I put.
Yeah, 0.2.
So do we say type of test greater than or less than? Because they're saying that 20% outperformed then, but I guess we don't really know what we're. All investment managers.
But what do you have? It wants the lower bound and the upper. What do you guys have?
0.000 and 0.002.
Okay.
Yes.
That's what I got. So what do I put? 0.0?
Wrong.
I don't know. I guess we'll try it. Bunny. Suppose you've been instruct immersion error 2% when So what are you guys doing right now? Are you doing number 28?
I was just writing a notes about finding X.
Oh, yeah.
Yeah.
Because that wasn't as clear in my notes. So I was just trying to add that.
Yeah. So X is a proportion mean then, right? Or no? Do you guys know?
For 28?
No, I'm just asking, is X the proportion mean then?
Oh, yes.
I thought
Is
deviation.
X is, yes. X estimates the mean. Wait on X
Oh,
bar.
standard deviation. That's the standard deviation
Yeah.
of the population. That's the standard deviation of the p hat. Okay.
X is the standard deviation? Is that what you just said?
That's what I thought, but apparently I don't know.
If it's not, then all of those answers are wrong.
Yep.
Standard deviation is that square root p 1 minus p over n. So
that's not an X though, is it? Standard for one sample z-test for a proportion.
we just plug that in for our x though. The 0.028.
Is standard deviation X? And you're not talking about X bar, you're talking about X, right?
Wait. X is the number of respondents. Right?
So that'd be 50 or 0.2.
Oh, wait, no, sorry. That's just in, I guess, a survey. That's the categorical data. X is the number. So, yeah.
What is X? X is P, right?
X is...
Or P hat. Yeah, that's what X is. X is whatever sample portion.
Well, P hat equals X over N.
I think.
And so, yeah, so...
So P hat is the sample proportion, but maybe X is the number of people that are out of your population.
Which would be 50 people.
Yeah. So...
So we should put 50 as X, and then the null hypothesis 0.2.
Yeah, I think that's right. So then we need to go change those answers real quick.
Okay.
So lower bound.
Which might make more sense because I'm not sure would 0.00 just seem strange, but possible. I'm trying to remember if I saw a 0.00 answer.
Yes, this makes so much more sense. Okay, so X is the number out of your population.
Yeah. And then P hat is a proportion of that number. Which means I've got 0.190 and then 0.310 is the upper and lower.
Yeah.
Is that what you guys got?
I got the same. Yeah.
Yes. Yeah.
Well, we'll see, huh?
Yeah.
Okay.
Good thing you didn't start the exam today.
What?
Good thing you didn't start the exam.
Yeah.
Oh, it's what Anna said. She said you got to, what was it? You have to remember what your X's and N's are, and that helps you fill it out properly.
Yeah.
xn. Oh, it's so confusing.
We needed to construct. So right now we have a margin of error of 0.19 plus 0.3 divided by 2. So that's 0.25 is the margin of error that we have now. This question confuses me.
So now we're trying to find the sample size.
Oh, yeah. Okay. So
it's n. We got to figure out. Oh gosh, I've forgotten how to do this one because it says to construct a margin error of 2%. What sample size would you need? Oh no, it's okay. So it's n equals. Let's see my formula. Equals what is our x? X is 50.
50.
So we're trying to find the number. Okay. What sample size? Isn't the sample size n? Or no?
Mm-hmm. Yes, n. So we're trying to find n. So isn't it that if p equals x divided by n, use the prior estimate though. So it should be 0.2 brackets something, isn't it? 0.2.
So 0.2 is the p hat. So 0.2 equals x. What's our x? 50 divided by n. But we're trying to find a 2%. 0.02? Would you do 0.02 equals 50 over n? No, because that's not margin of error. That's what I'm confused. How to calculate margin of error. I think I'm just forgetting it.
You have to use the prior estimate.
Margin of error is that big equation, right?
Yeah, let me see it here.
Wait, is it the standard deviation over square root of n? Maybe not. Maybe that's a z
Margin
square.
of error, it's, yes, wait a minute. Yeah, it's H5.
So 95 is 1.96. 1.96 times. What's our standard deviation then? Over n. Would it be the 0.02?
Oh, that would be, wouldn't it? Because that's the prior estimate, wouldn't it? Point.
Oh, wait.
Or 0.2 would be.
0.2. So I'm wondering if we do 0.02 equals 1.96 times 0.2 over n. The 1.96 is because we have a 95% confidence interval.
So we still want to find the margin of error, right?
Yeah.
So it should be 1.96 multiply the square root of that.
Multiplied by the square root of, oh,
1 p and 1 minus p, something like that.
but is the standard deviation the 0.2 that we're talking about? Use the prior estimate of p star equals 0.2. What's p star? I forget. Do we have a p star?
Yeah, I just think it means prior estimate.
I have no idea on this one.
Yeah. We don't have to get 100%.
Yeah, we're
let's,
going to have to skip this one. I'm even trying to look up prior estimate to see if I could remember if it rings a bell. And it's. Let's
So
go on.
it should
Come
be,
back to that one. I want to try.
So
but
the
yeah.
point estimate, it's the p hat 1 minus p hat 2.
I don't know. Point estimate. Wait, the point estimate is the mean, right?
I thought the point estimate was p hat 1 yeah, but we don't have two values there, so that's what I'm talking about.
Yeah, I think the formula is n equals p hat brackets 1 minus p hat that's in brackets, 1 minus brackets, and then you do the times the brackets of 0.9? Yeah, 1.96 divided by something squared. What is that? I think that's the formula, but I'm just not sure. I can't remember. So it's the z-score 1.96 divided by the margin of error, 0.2. Divide by 0.2. Is that ringing a bell? And then you square it.
Wait, we're trying to find the margin of error of 0.02. All right, let's skip it and come back. I think the next one is the second to last one, for p 0.2, or p is greater than 0.2.
So we already got the upper bounds and lower bounds. So I think, yeah, something to do with those.
P is normally distributed.
Oh, yeah, don't we use that 0.190 and the 0.310 in numbers 26, 27 to find the margin of error? And then we calculate, which we'll do later, but isn't that what we're missing?
So, no, because that's the margin of error currently, but so we have the margin of error of 0.25 right now. So they're saying find the margin of error where it's 0.2, right? 0.02. 0.190.
What number are we on now?
We're now going to skip 28 and do 29. Can we do 29 without doing 28?
Yeah.
Okay.
I think it's the second to last one because they're saying, suppose you wish to see evidence. Top 10 performs better than other investment managers. So I think it's P is equal to is the null, and then P is greater than is alternative.
I agree. Wait on. Oh, you said second to last. I was looking at the second one. Okay. Yep. Second to last. What requirements must be met to ensure that P hat is normally distributed?
I think
That's
that
the top one.
Yeah.
Okay, because 5 is the one for the, isn't it, for the chi-squared test?
Yeah.
So value of your test statistic. Oh, do we have that all keyed in?
So whether 29.
1.768, right?
Yep.
P value is 0.039. We're gonna reject the null. Yes, I rejected the null. So the first one. Oh, I'm so tired.
You're almost there. Is there sufficient evidence? Reject. Yes, I rejected HO. All right. I was just checking that my Excel sheet was correct, so I'm catching up now. All right.
So
we got to key this in the blue scores thingy. Let's see.
yeah.
And this one.
So this would be 1 proportion. Oh.
You hear what I'm talking? If it was a real exam, at question 34, my brain would be fried.
Oh my gosh, I know, me too.
Hey, where did my Excel sheet go?
So do we use which one do we do for this? My question. Oh.
There we go. Found my data. So now I've got to plug it all in. So it's 1. Which one is it?
Is it the 1 sample test just from our last one?
Is this our 1 sample, or is it the other category? Are we still on the same?
I think we go to quantitative inference procedures. This is a 1 sample t-test. That's what
I'm thinking. Wait, this doesn't look like it's going to fit in this. Okay.
Yeah.
Let's see if we got the right test. Okay. And then copy it into that. Okay, so I've copied mine in, and now we're saying mean score 0.295.
You have 0.295?
Yeah,
No, that's
the
what
mean
it
score.
says. It says he wants to use this data to see his mean blues score differs from mean blues score of another, which has a population mean. Oh, it's talking about another one, sorry. The other one has 0.295. Okay. 300 sentences, 100 boxes.
So that's the null hypothesis then, right? 0.295. Is it? Because he wants to see if his differs from. So that score is the null hypothesis, and then we do not equal to. So for the lower bound, do you guys have 0.282?
Yes. Does it has a null hypothesis of 10. Is that right? And greater than.
No, the null hypothesis is 0.295 because he's comparing it to the other translation software. And he's doing not equal to.
Okay. All right. Yep, 0.282 and then 0.293.
Mm-hmm.
Okay. And then we're saying calculate the degrees of freedom. Okay. Okay. All right, what have I got? 99. Can I just put 99 or you think I should put 99.0?
It's fine at night. I'm sure. What?
It should be fine, 99.
Okay. And then I got negative 2.0803.
Mm-hmm.
Wait a minute. So we rounded this to 2.08, right?
I'll round to 3. Okay. And then.
Are you talking about the p-value, Elvis?
No, the test statistics.
Oh.
There's no rounding though. It's just that number, isn't it?
Round to 3 decimal places, no?
Yeah. I only have 3 decimal places. Do you have more?
No, my number is minus 2.080.
Oh. Mine's negative 2.803.
Yeah, that's what I have.
Oh, okay. So.
And then 0.006 for the next, for number 38. Ugh.
So it's bigger than the alpha. Find something bigger.
It's smaller, right?
No, it's alpha is 0.05. We have 0.06.
Yeah, 0.006 though is smaller than 0.05.
Mm-hmm.
That's 0.05. The alpha.
So then, so we have sufficient evidence to say that the true mean is different.
Yes.
So the first one.
Yeah.
Okay. Oh my gosh, there's 6 more. I thought it was just 3 more. I thought there was 42. Oh my gosh. Okay,
Here,
these ones should be because it's an Excel sheet.
Yeah, hopefully.
Okay.
Lower. Okay. 45. This is the last one.
Tolerance.
So this is the 2 paired or 2 sample t-test.
Paired.
Okay. I just realized I didn't read it. I'm just copying and pasting right now.
Lower back. Seriously.
Just
Okay. Okay, so I have got. Yep, paired. Okay. Lower bound.
8.728.
Yes. Oh my gosh. 8.728. 10.455. That's what I got. Two 2.446.
Yes.
$40 for the degrees of freedom.
Mm-hmm.
Okay, 2.795 for the p-value. Keep scrolling too much. No, yes, because we failed to reject the null. So shall we just submit and figure out that margin of error another time?
So just so you know, question 2 is the chi-square test of independence.
So it's the one you thought, right?
Uh-huh. It's because we were seeing if they're dependent or independent.
And so that's the key, that those words. It didn't matter whether they're two groups, one group, it was that wording.
Mm-hmm. And
Okay.
then we got question 5 wrong.
Question 5.
so. Question 2 for what was that?
2 is the chi-squared because it's dependent or independent. Kitty.
Oh.
Number 5, that one is
Well, it's 1 a.m. in the morning, so it's not working my brain.
Okay. Yeah. Go to bed.
Yeah. I'm just waiting. So what else we had to?
so is it just number 5 that's wrong?
No, we got a few more wrong. Do you want me to tell you the wrong ones real quick?
It's up to you. I don't mind staying on if you want, but I can take it in case you get tired. 5.
No, I know. Let's see. 5, 6, 7. We got wrong.
All the theoretical questions, yes.
And then 14. We got wrong.
Okay.
28.
Not too bad, but it's still a lot.
Yeah, 28. We got wrong.
Oh, that's one we never figured out. That's why.
Yeah, we didn't put anything. And that's it.
Oh. So it's probably because we got, yeah, I'm trying to remember this one. I just saw this one. If it's a lock and you're timing it, I think we just had it.
Probably.
I can try something so that we could know for sure. It's.
So it looks like we all need to study the type of tests and what.
Yeah, we're all so close. It's like we remember and then.
Yeah, then we don't. Okay. I'm going to hop off. I'm ready for bed.
All right. Thank you so much. We'll catch up with you. Now, we just leaving things to Tori. There's nothing we need to do as a group you need from me.
No,
Okay.
I'm hoping she'll come on Wednesday. And
we don't have a on Wednesday, do we?
Oh, you're right. So I guess we're good. And then we just need to check up with Tori, make sure.
Okay.
She's good.
All right. Then I'll just catch up with you guys next week then.
Sounds good. See ya. Have a good week.
Thank
Good luck.
you.
Yeah.
Thank you. Yeah. Good luck,
you too.
everyone.
See you
Bye.
then. Bye.